Hey guys, I want to go over a few things on our first lab, the introduction to DC meters and power supplies. So let me bring that up and just want to hit a few high spots. Most of you did fine. There's just a couple of things I want to emphasize to you. So here was the lab, that you went through, and of course we did this virtually using the videos and the multi-sim access. And the first part is, just a description of the lab, what's going on, the equipment used. This is, of course, what we actually have um, in our fourth floor lab. And then the first thing was to go through and, determine what the color code would be for particular resistors. And in this day and time, with the um, availability of you know, internet, there's really no reason to miss that. I mean, you can just go online and find all these color code apps that you can make the determination with. And what I wanted to show you and make sure that you were doing uh, was, I think most of you did this, but to make sure that when you entered the tolerance for a particular resistor, for instance, say I had the first one, it's 470 ohms, and it, had the gold band indicating a 5% tolerance. What I wanted you to enter there in the tolerance is, plus or minus 5%, and what would that actual value be? Okay, so for 470, to find the minus 5%, I'm just going to say 0.95 times 470. And when I do that, I'm going to come up with 0.95 times 470. I'm going to get 446.5, which would be on the low end here. So I would enter that here. And then on the high end, it would be 5% above. So that would be 1.05 times 470. And so that would come out to be, let's see, 1.05 times 470. And that comes out to be 493.5. So, that would be the range across there. And that's what I wanted to see that you did on the tolerance. So when you got a particular resistor, like for this one, and say I measured, 490 ohms, and it says, is that within tolerance? Then I would want to say yes across there. Okay. So that was one thing I saw. A lot of people, not a lot of people, but several people just wrote 5% or plus minus 5% in there. But what you're wanting to do there is to put the actual values in there. Okay. Didn't really see any problems here. That was good. All these looked good here with the amp meter readings for multi-sim. Again, these look good. On the discussion of results here, don't be shy, and come on and give me a little more information than maybe a lot of you did. Maybe do a little background reading, the importance of knowing the band structure for resistors. One thing that was pointed out, I think this is probably in your textbook more than anything else, the color bands, it's actually for identification of the resistor. Some of these components are very small and it's hard to read printed values on there. So there's this adopted color code. The other thing about that, that's a universal thing. It goes beyond languages. And that's another reason. Differences in VOMs and DMMs. A VOM is an analog device, and one of the advantages of an analog device meter is that you can actually see movement on the meter. It's got a needle on there, and if you're seeing changes or it's switching or deviating, you can actually see the needle move. So there's certain applications where that's important. The main disadvantage is interpreting that last digit of accuracy, where you have to do some sort of, a reasoned estimate. The digital multimeter gives you that, specific number that you don't have to do any type of calculation on. Where you get a question where it's saying, like an E, what did you learn? Try to avoid saying such things as, I enjoyed the lab, it was cool, that sort of stuff. Just go back and look at the reasons for doing the lab, and those are usually given to you in the first part here. And, it's sort of a going back and acknowledging that you actually learned that material. The lab quiz, I think everything was good for that. One thing I'd point out on number 3, if you don't have a band on the resistor, it's assumed to be plus or minus 20%. And then number 4, it's a problem. We have this basic, let's see, I think I can do it down here. We have this formula for resistance. Resistance is the resistivity times the length over the area. And so what it's saying here, and what I would do if I run into a problem and I have trouble with it, but what it's saying is a piece of material with resistivity, length, and cross-sectional area A has a resistivity that's increased by 50%. So really what you're saying is that this resistivity is 1.5 times the original, right? You increased it by 50%. And the length, which is also, in the numerator, its length is increased by 100%. So you're basically saying 2 times the length, right? And then down here, you're saying the area has tripled. So you're saying 3 times the area. Okay. So I'm not going to answer the question exactly, but that's one approach that you might use with this. Another thing that I do, or I used to, do this in like in a math class when I was teaching, that sort of thing. If you're having trouble seeing a relationship like this, then put a real number in here. Okay. And say that the resistance is 100, and I'm going to say the resistivity is 2. Oops. The resistivity is 2. I'm just making this up, okay? And the length is 5, okay? And then I'm going to say the area is, I don't know, 10. All right. So, well, I should have come up with something that's, I'll make that 50, okay? And this to be, I want it to come out to be the correct number. So 2 times 50 is 100 divided by 10. So I'm going to make that resistance 10. Okay. So 2 times 50 is 100 divided by 10 is 10. Now, if I double the resistivity, excuse me, not double the resistivity, but if I increase it by 1.5, right? So, 1.5 times 2 is 3. And I double this to 100. And I triple this denominator, that's going to be 30. Okay. And I want you to see that relationship. And again, I'm not going to just give you the answer. So because some of you haven't turned that in yet. And then the other thing I would say is if you didn't get, well, most of you that completed it got a really high grade, a 98, a 99, 100. If you missed something, you left something out, like I couldn't find your discussion. If you want to send that in a separate or an attached, that's fine too. Or maybe you just really messed up the lab quiz. I wanted you to rework it. So I might have entered a 0. What that means is I want you to go back and fix it, and I'll give you another attempt on it. Okay. So get in touch with me about that. Let me know if you have any questions.